I think this is recording right now. So I'm going to start going through it. Alright, first you got to know this one is what XY is. So there are two endpoints, XY. We're saying what's the length of that line segment that's going all the way through. I know it's a line segment because on the top it has a little line segment, right? And then we've got our angle addition postulate that says that xc plus cy is equal to xy. So six plus 12 would be 8. On this one, we've got this family going for a drive, and they're going from 0 to 440 miles. And so far, they've gone 66 miles, which maybe puts them about here. And it wants to know how long until they get to their halfway point. Right? So what's halfway from 0 to 440? 220. So this question is just asking, how far is this, right? So it means how far until they get to that halfway point. If that's not clear, if you're looking at this problem and you're like, I don't know what they're asking me for, draw it the same way I did. It's a really smart way to do it. You get a nice visual picture of what it is you're looking for, and you don't accidentally make a mistake on some problem. What's that? Blocks. So how do I figure out this distance? How do I figure out this distance? Right, what? Oh, what's that? 220 minus. And what is that? $154 miles they gotta go. It's a pretty short day driving on a road trip, that's right. I also kind of broke these up so you can see which diagram goes with which problem. So it's clear on. Alright, this one's going to have kind of the same, all three of these are really kind of the same thing. Looking at segmentation. I put these together. So if I put what I know on here, like before I even get into the numbers or anything, I just don't care. The segmentation postulate says that if I take this piece, Ln, and I add this piece, Mn, the result is the entire thing. A very simple concept. If the two parts make up the whole, I add two parts together, I get the whole thing. But it doesn't change the fact that half of you looked at this problem and you're like, I don't know what to do. And so even though it's simple, you got to make sure that you understand this idea. What you're going to do is just write that simple concept down. It makes everything so confusing. Because now I can just say, what expression goes with Ln? 4x plus 8. And what expression goes with Mn? 27. And how about Ln? 6x. And now I have an alpha problem too. So I got 4x plus 35 is equal to 6x. If I add that 8, 27. And then I will subtract 4x from both sides. And now I've got 35 equals 2x. Divide both sides by 2. And x is going to be 17.5. But that's not what they're asking for. The question says to find Ln. So here's L, here's N, I want this whole distance. So what should I do with the x? Multiply it by 6, yeah, because I got this 6. Okay, 6x is that distance. So if I just take 6 times 17.5, that's 105, right? And we don't really have any units, so we'll figure this like that. I'm going to keep on going kind of quick just because we're recording. But I'll always follow you because you guys are going to do the same. Okay, so for question number 4, I've got line S. Here's the S right here. So we're talking about this line. And so I'm looking for other names for those. So one name I could say is I could actually write out line S. Another option is I could say that it's line XU. Like that. I could also say that it's line UX. Or that it's line RU. Or that it's line UR. Or XR. Or RX. Every single one of those describes the exact same thing. You only, of course, have to put one of them. Looks like for this question, there are 6 right answers. That's going to be the case with a few of these. There are going to be multiple right answers. Same thing for this one. Name 3 points that are coplanar. Well, really, it's going to be any 3 points except for X and U. I'll leave one up here so we have that answer. But if I look at those 2 points, those are the only 2 that are not on the plane that's drawn, right? So I can pick any 3 of the other points and put them on there. So I could say Q, T, and P. I can't say K. Why is that? It's the name of the place, it's not a point. There's no dot next to it. K is not a point. All right, it's the name of the point. And so I've got these 5 points in here. T, R, Y, P, and Q. I can name 3 of them and name them. Now, if I want to name 3 points that are collinear, I have 2 different options. I could go this way. Those are all collinear, so I could say X, R, and U. Or I could also go this way and say T, R, and Y. Notice how I'm writing them differently. I don't put any lines over those or anything like that, right? Because they're points. I'm making a list of 3 points. Whereas this one, I'm naming specifically a one. And then on this last one, give another name for plane K. It's, again, any of these 5 points, T, R, Y, P, and Q, except that they can't be collinear. So as long as I stick to these 5, the only way I can do it wrong is if I chose T, R, and Y. Because if they're collinear, they don't define a plane. Okay? So anything, I can put this exact same answer if I want. Q, T, and P. But you write it different. You don't put Q, comma, T, comma, and P. Because we're not making a list of points. We're naming a plane. So now I would call it plane QTP. This actually might be one of the trickiest parts of the test. track of these names. It's okay. That's not good in terms of because, you know, if you put like plain Q comma T comma B, wrong. You know, like it's details. And I know that so many people look at this like, oh, it's so simple, it's so obvious. But you're overlooking the fact that the details, you gotta have every detail correct. If this line right here didn't have arrows going in either direction, it's wrong. So just really make sure you understand exactly what each little piece means. And whether you're naming a point, a line, a ray, a segment, or a point, like that's gonna be the first thing that you learn. This is going to be a distance formula question. We can plot the points because it tells us to, but we don't really need them to figure it out. But there's A, B is going to be -1, 3. C is 2, 0, and then D is 3, -1. So what we're trying to compare are those two distances. Let's see for example. But it might be something that looks a little bit bigger. You gotta check. So if I find AB, I'm just going to plug that into the distance formula. So using these points, here are my x values. So I can say it's going to be -1 minus a -4. And then y values are going to be 1 and 3. So I'll put 3 minus 1. And if I start putting this together, -1, it's -1 plus 4, right? So that's 3 empty space. So this is going to be 3 squared plus 2 squared is going to be the square root of 13. I'm not going to go any further because I'm going to look at the next one and see if they come up with the square root of 13. If it does, I'll know that they. So for the other one, CD, same idea. Distance formula. My 2x's now are going to be 3 and 2. So I'll have 3 minus 2, which would be 1. And then -4 minus 0. So I got 1 squared plus a -4 squared. Of course, when you square -4 could have to be a positive 16. So if I put those together, I get radical 17. Are they the same? Radical 13 is the same as radical 17. So we would have to make that statement somewhere that A, B, and C, D are not. Just to make sure that we answer the question correctly. This one's going to be a midpoint formula problem. So that's the midpoint formula. That'll be given to you when you take the test. Either on your sheets or written on the board or something. So these two are these two x's. So I've got 1 plus 7 over 2. And then these two values are those two. So I've got -6 plus 5 over 2. So this will be the 4, and then negative This is the trickier kind. So this is the one where we're going to kind of set up what we know and what we don't. So in this x spot, I know that if I take negative 6 plus something and put it over 2, that puts it in a different one. That's negative 6 from here. And then I got a positive 6 here if I do 6 plus y over 2. That gives me the y coordinate. Well, I also know what these points are. Here I've got 1. That's what's going to be the coordinate, right? It's right there, it says coordinate. And then right here I have 2. So then I was going to go here. And so then I just have to recognize that these things they're the same, right? I got to match them up. So for the x coordinate, I take negative 6 plus x over 2. And set equal to 1. Multiply both sides by 2. And so negative 6 plus x has to be equal to 2. And if I add 6 to both sides, I get x equal to 2. Same idea over here. I know that 6 plus y divided by 2 has to end up equaling 2. Multiply both sides by 2. I get 6 plus y equals 4, and then subtract 6 from both sides. Y equals negative 2. So those 2 points, my answer, I have to put in the form of coordinates, right? So put a coordinate to the midpoint. So my answer to this is going to be 8, negative 2. If you wanted to check that, you could always plot it. That last one is a question, should look like a quiz too, you may remember, where you have to find the other input. This one, this grid didn't show up on your review very well. I was trying to solve it on there, I couldn't put it in the but on here I can see it. So really, it's so simple because it's on the grid. I don't even know if you can use a physics formula. I could, but I can see, well, I guess one thing I have to keep in mind, yes. Oh yeah, it's not on the test, that's why. Yes. Yeah, you can just cross it. On this one, each little distance is 2, is like distance of 2, right? Each grid space. So this is going from negative 4 to 6, right? How far is it from negative 4 to 6? A little further. It's 10. From negative 4 to, it's 4 to 0, then 6 more, right? 10. And then going this direction, I've got, this is negative 2 here, negative 4, negative 6, and this is negative 8. So how far is it between negative 2 and negative 8? 6. And that's really all the information I need, right? So now if I wanted to find, it says perimeter and area. The perimeter is going to be 6 plus 10 plus 6 plus 10 is 22. No, 32, sorry. and then the area is going to be 6 times 10 is 60. They may, a lot of times in the book they put like units, like literally the word units. But I don't care. If I don't give you units, you don't have to give me units. So these answers are good. Now, if I said it was feet or something out here, you have to say square feet for the area. We're getting close. No, it's boring. Let's get the opposite test. Okay, this one, these are kind of easy questions in terms of the math part, but you just need to know what they mean by identify the segment bisector of segment XY. So how would you identify it in this question? What's bisecting? What's bisecting segment XY? Kind of both of those things, but L is not really a point, it's the name of the line, right? So I would have to call this, when I identify it, line L is what is bisecting. And then how long is it from X to Y? What's this whole distance? Okay, I'll make it. No, those hash marks aren't splitting anything in half. They're just telling you that those are the same length. So the little hash mark, these things right here, they're not part of the diagram. They're just telling you that XM and MY are both the same length. They're both something. So the XY squared. So what about this one? What's bisecting it? You gotta be careful, right? It's a ray. And whenever I name a ray, what do I have to start with? M or L? I have to start with M. You've got to start with the M point. You've got to know that. It's very important. Because it tells you the direction. You start here and you go to L. That tells you where that ray is going to finish. So I've got ray ML with the arrow only on one side. A lot of pieces, details, remember to get this question right. And then what's the distance XY? 18. So this is where you have to be careful when you're studying. Because you look at this question, you're like, oh my gosh, 9, 9, 18 is the easiest question I've ever seen. I don't have to study this. Then you come to take a test and you write line L right here, you just put it wrong. One of the easiest questions on the test. Don't do that. Make sure you know what you're doing. All right, here's the key to all these. That's funny. It's kind of already underlined with the grammar error. But this idea of bisects, it means that both these angles have the same measure over here. So if they tell us that ABD is 57, then what's DBC? 57. That's pretty nice, huh? So what's the whole thing? 114. That's the max of it. So just make sure you're writing your stuff down. So measure of angle DBC is 57 degrees, and the measure of angle ABC is 140. Then they do this exact same problem again, but they switch it. ABD is now 70. So what's DBC? 70. And the measure of angle ABC. And they get a little tricky on the last one. And they say, this whole thing is is 110 degrees. So what's ABD? 55. But all of that is predicated by the fact that it's a bisector. So that's the only reason we know that is because it specifically says bisects. Our last little batch, 4 questions, I think. Angle B is a supplement of angle A. What that means is that angle B plus angle A is equal to 180 degrees. They say that angle A is 65.2. So angle B, yeah, I just subtract from both sides and get the angle B 114.8. I suggest writing this step right here. I know you all love this stuff. It makes it so easy. Exact same question, but now it's a complement. So angle B plus angle A equals what? 90. It's a complement. So angle B plus angle A is at the 65.2. Subtract 65.2 from both sides. Angle B is 24.8. It's going to be a long video. Sorry. Last two, these are going to be the same thing, but the answer is going to be an expression. So I'm going to write my same thing out. A is a supplement of B, so angle A plus angle B is 180. And then angle B, it says, is 3x minus 2. So if I add 2 to both sides, I've got 182, and then subtract 3 from both sides, I get this expression. So I don't know what x is, but I know the expression that represents the measurement of x. Last one. Same situation, but now it's a complement. I'll write all the steps this time. Pretty much the same question, it's just 92 instead of 182.